Now, as far as solving a quadratic equation, based on how it looks, we want to be able to figure out what x could be. And there's different kinds of quadratics. Okay, all quadratics got to have is have to have a power term or have variable multiplication. So if you just saw a quadratic, and here's what I'm saying, no guts. If there's no middle term, if you just have ax squared and there is no middle term with x, you can solve it just by using square rootage actually. So here I would divide by 3, x squared equals 9, I would square root. Now the thing you got to do remember though is there's two answers here. You can square 3 and get 9, or you can square -3. Either one of those will be the solution on that. There's actually two sides to that parabola that are going up and hitting 27. Okay, similarly here, -10 minus 10, 4a squared equals 32, divide by 4, a squared equals 8. We square root. You will always have a plus or minus in front of that thing because there's two sides to the parabola. Now, this is going to be an irrational answer. Square root of 8 is somewhere between 2 and 3, closer to 3, because 3 squared is 9, 2 squared is only 4. But you can leave it in root form and simplify, that'd be 2 root 2, or you can use a calculator and you get like 2.83, I think, if you round it. Okay? Alright, now, here's some other quadratics. Every one of these quadratics has guts, alright? And when a quadratic is in standard form like this, you can't just use rootage because it's not just a square that you're undoing. You also have a middle value you have to compensate for or deal with. So when you have one of these, the thing I would say is if you can factor it, you should factor it. Okay, break it down by factoring. So you've all been taught how to factor. We have to come up with things that multiply to make x squared. Well, that's x. The last times the last has got to make the last. I mean, we're talking about the FOIL deal here, aren't we? So first times first is first, last times last is last, but one eyeball's got to be on the middle coefficient. Because I'm looking for combinations of factors that multiply to make 20, they got to combine and make 9. So I don't want 120 or 210. It's got to be 4 and 5. And they're both positive to make positive 9 for the middle. Now, I have not solved the problem. I've set it up now where I can solve the problem because solve means find the answers for x. So now I say, what could x be to make it 0? Well, x could be a -4, or x could be a -5. And what we're talking about is where that quadratic, that parabola hits the x-axis. Okay? So you have to put your quadratic in standard form. If it's got guts, put it all together on one side. So here I've got x squared minus 6x equals 40. This 40 is going to come over here. X squared minus 6x minus 40 equals 0. From that point on, if you can factor it, we factor it. This is a factorable quadratic. You can break it down into a simpler form. Two numbers multiply to make 40 and the difference is 6. 4, 10. -10, positive 4. Now the answers then would be -4 or positive 10. Okay? Now this last one here, again, it's got guts, we're going to put it into standard form. Everything goes on the same side as the square term. That is the leader. That'd be like if President Obama walked in the classroom or into your room or wherever you're watching this, you turn the video off and go follow your president. So, everybody wants to go on that same side as that positive leader. So 2m squared, -20m, positive 50 equals 0. If you can remember here, there's a GCF. You can take a 2 out of everything here, divide everything by 2, m squared, -10m, positive 25 equals 0. And then this factors. You're going to get m minus 5 times m minus 5. So the answer actually is just 5. Now you say, wait a second, how come there's only one answer? You said there was going to be 2 answers. Well, what happens with this particular parabola, it only hits the x-axis in one spot. It comes down to 5 and then the function goes back up. Okay? So, if it's got guts, we're going to solve it by factoring if we can. If it doesn't, okay, we're just going to use rootage. Okay, I guess that was up above. Okay, now, there's one other way to solve quadratics, and it works every time no matter what form it's in, or no matter if it's got guts or not, and that's called the quadratic formula. Now, the quadratic formula, you can use it if it's in standard form and you cannot really factor it. Okay, now, this is an example where you could factor, so it's kind of cheesy to use it, but I'm going to show you. Quadratic formula is a formula they'd have to give you on the test. It gives you the x-intercepts of the parabola, and the solution is x would equal negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay? That's a mouthful. That equation would be something that they would have to give you on the test. You're not expected to memorize that. But you need to know that a is 1, b is 9, c is 20, and I can solve this equation using the quadratic. Excuse me. So negative b would be negative 9 plus or minus the square root of b squared would be 9 squared. Negative 4 times a times c over 2 times a would be 2 times 1. And essentially you just work this. Negative 9 plus or minus square root of 81. Let's see, that would be minus 80 over 2. Negative 9 plus or minus the square root of 1 over 2 now. This root in here is either going to have a positive number, 0, or a negative number in there. If it's a positive number, it means it has real roots. It has x-intercepts. Okay? And it's either a nice number that you can root or it's not. Well, 1 is a perfect square number. Square root of 1 is 1. So what I really have is negative 9 plus or minus 1 over 2. The quadratic formula has the plus or minus built into the formula, so it's already considering that there's two sides to the parabola. So what you need to do here then is split this off, negative 9 plus 1 divided by 2, or negative 9 minus 1 divided by 2. Negative 8 over 2 is negative 4. Negative 10 over 2 is negative 5. And there's my answers. Okay? Now, you can't use the quadratic formula unless it's in standard form. So, this problem I'd have to bring the 40 across before I did my negative b plus or minus square root of b squared minus 4ac over 2a. This one's in standard form. Quadratic would work just fine on it. Okay? If you get a negative number underneath the root, that means there's no real solutions to that problem. The actual solutions are involving complex roots with numbers. So, that's not going to probably be the case, but where they'd have something like that. Alright, that's it, solving quadratics. It depends on how they look. Sometimes you can just use rootage if there is no middle term or no gut term. If there is guts, put it in standard form. If you can factor it, factor it. If you can't, quadratic formula will get the job done for you. Alright, that's it for today. Take care, and we'll see you on the next time.